Alright, welcome back. Now in this tutorial, we're going to consider one of the most important concepts that you're always going to come back to refer to, right? That is overfitting and then underfitting. Okay, so beginners who are trying to learn data science or machine learning in particular find this kind of topic quite interesting, right? So they will be hearing overfitting, underfitting, especially if you have not gone into the various machine learning algorithms and then you are just getting started, right? You'll be hearing people in the industry talking about overfitting, underfitting, and then you start to get interested in it, and you become very, very much inquisitive to get to know what overfitting and then underfitting is. All right. But it's a very crucial concept. In machine learning and in deep learning, in AI in general, overfitting and underfitting is a high concern over there. Okay, so let's get to understand in this particular tutorial. I'm actually going to make it very interesting for you, and by the end of this tutorial, I'm very, very much sure that you're going to love it and you're going to understand it very clearly. Okay, so let's get started. Over here, we're going to use real examples over here to get to understand it, right? Before we even think of any, any machine learning kind of relations, we want to relate it to the real world so that you get to understand it very well, right? So let me give you, a head start over here, right? Now, if you see the image that you have here, if you even forget anything that we're going to do, remember this particular image that I've put over here. Okay, now if you consider this first person that is here, right? So they want to buy a short. Okay, so this is a person who wants to buy a short. Okay, this is a person who wants to buy a short. Now imagine you order a short from Amazon or from any other eBay or any e-commerce website over there, right? So imagine you order this kind of a short over there, and then when the short comes, it's like too tight for you to even wear it, right? The short is too tight for you. In that case, it is what? It is underfitting you. Okay, it is underfitting you. Okay, it's not fitting you well, right? It's not fitting you well, but it's not that it's oversized or something. But if you try to put it on, you can see that it's really holding your waist like you owe it some money or something like that. It's really underfitting you. Now, let's say you got your perfect size, right? You're able to select the size very well, and you got the perfect size. In this case, we call it normal fit, right? Or best fit, right? You can call it normal fit, right? Or you can call it best fit. Okay, normal fit or best fit. And that is the real size. That's the size that you want. Okay, but especially if you are ordering things from online, it's very, very much possible that the thing comes and then you see that the thing is underfitting you or is overfitting you, it's oversized. Okay, the thing will become too big and then you have to return it. Okay, when the thing comes and it's too big, we call it overfitting. Okay, in this case, we will call it overfitting. Okay, or oversized. You can call it oversized. In our normal world, we call it oversized. Okay, now this is a common scenario in our daily lives, right? Where we order things online and then it comes whether top or short or whatever it is, and it doesn't fit you well. Even shoes, right? If you're not able to choose the right shoe, it's either the shoe is going to pinch you, right? And then you will not able to wear it for some time or a long time. Okay, or it doesn't really fit you well, right? It's oversized. Okay, but if you have your the normal size, then you're good to go. Okay, so if you forget anything, just put this image, just remember this image, okay, and you'll be good to go. Now let's consider another real example over here, right? Let's go back to school over there, right? Now in our normal college days, right, we can define some class of people that we normally associate with. So let's consider this to be a math class, right? Or maybe data science or machine learning class, right? Let's just stick to mathematics class, right? Now in the mathematics class, we have different categories of people in the class. Okay, so we have in this case, we're going to consider three kinds of students over here, right? Student A, student B, and then student C, and then with their professor over here. Okay, so let's describe these students in details. Okay, so we have student A over here. Now this student, what she cares about is chatting on phone and Instagram stuff. Is becoming Insta famous, and I mean, on Facebook, always trying to dress well, doing her hair, I mean, doing the hair well, and trying to impress the guys. You know what I'm talking about, right? In the school days, you know what I'm talking about. Trying to dress well so that, I mean, the guys who have something in their pockets will be attracted to her, and then they will take her out and maybe probably date her or something like that. Okay, so that she will also get something. I mean, you know what I'm talking about in school days, right? So just think about it that way. So that is our student A, right? She doesn't really pay attention to the professor and doesn't really care about what the professor is teaching. She just want to have some pass marks and then go. But the main thing or the hobby that she likes doing is just chatting and you know, trying to impress the guys in the class or in the campus, right? Now, there's this student, right? There's always this particular student who is always over serious in the class, who is want to be the top of the class, right? That person is always want to be the top of the class. Always is marking everything that the professor is teaching in the class, right? You can think of marking as memorizing, okay? Think of marking as memorizing, okay? So he just makes sure that whatever the professor has taught in the class, he memorizes everything, come to the class the next day. If the professor asks any question, he answers. He just wants the attention, right? He pays too much of attention to the class. Okay, there's always that particular kind of student, and I'm sure in your I mean, during your days too, you've experienced that kind of person. Okay. Then there's this particular student, which is student C. This particular student C, right? She's not that serious like student B. Okay, she's not that serious like student B. However, this particular student is also very much interested in what is going on in the class, right? Her hobby is learning new things, right? She pays attention to new things and she wants to know what is going on. Okay, she's eager to learn some concept, right? She pays attention in the class and then learns the idea behind solving the problem that the teacher is teaching. Okay. She's not that particular student who want to memorize everything and try to score everything to impress the professor. She actually is into the learning, all right, but she wants to know the idea behind what is going on, right? She wants to learn and then figure out things. Okay, she wants to know the process that went on in arriving at the solutions. So she's more like a problem-solving approach person. Okay. She's more like a problem-solving approach person, where you learn the process behind or the idea behind what is going on. Okay, and then based on that, she can come up with solutions. Okay, so you might be finding that person quite interesting. She likes asking questions a lot in the class. She likes going to the library and doing a lot of research, right? But that student, that one that I showed you here, right? This one. He knows that the professor, when it comes to the exams, the professor will bring questions according to what he has taught in the class. Okay, so this student will try to memorize whatever the lecturer is teaching, and at the end of the day, he will come to the class and then try to impress the professor or the students over there. Okay. Now, these are the kind of students that we have. Student A, right? We have student A, who is that kind of impressionist. Okay, she doesn't really care about what is going on in the class, right? Maybe home maybe they have some money already. She's not even under pressure to learn anything, or maybe get some good job and take some responsibility of some other siblings or maybe family situations. So there's money at the home. You know what I'm talking about, right? So what she cares about is just just get your pass marks, get a degree, and that's it. Okay. And then there's this one over here, right, who is the kind of a person who wants to memorize everything, become the top of the class, and pay too much attention in the class. And then this student who is the pragmatic kind of a person, right, learn the process, figure things out, and then find out why things work the way they work. Okay. Now, let's say the professor has taught. Now it is time for the professor to conduct some kind of a test. Okay, it's time to conduct a kind of a test. Now the professor sets the questions, right, according to what he has taught in the class. Okay, the professor gives them the test according to what he has taught in the class. Now let's say the result is out. Now let's see how the result goes. Okay, this is the result now. Now if you look at it carefully over here, right, now this is the student A, right? This is the student A who is I mean, you know what I'm talking about, right? The impressionist who likes to be on phone testing and stuff like that. So during the exam, approximately 50%, right? Doing some, some kind of gymnastics and skeptics over there, guessing work and stuff like that. She's still able to score like 50%. Okay, she wants her pass marks. She got it, right? And then Mr. Know It All is here. Okay, Mr. Know It All. He got 98% because he actually memorized whatever the professor has taught them in the class, and he also knows what the strategies of the professor, right? He has mastered that, and then he has mastered the curriculum and what the professor is teaching, right? And then there's this problem solving approach person, that is student C, right? She got 92, right? She liked to know what is going on. She's not that memorizing person, right? She doesn't memorize the concepts. She learned step-by-step approach, how things goes on, okay? And then she used the problem solving approach to come up with solutions to the questions. Now you can see that this person is the top of the class. That's what he wants to achieve, and he has gotten it. Okay. Now, at the normal circumstance, right, we have the school exams and then we have the national exams. Okay. Now, let's say they are going for the national exams. Okay. Now, at the national exams, it's not like you're going to have the questions. It's not like your professor's way of teaching, or your professor's questions, or his things that he has taught you in the class are the ones that are going to appear. Okay. At the national exams, it's going to be a different scenario altogether. Okay, the national exam is going to be a different scenario because it's general for every every student in the country, irrespective of the school that you are enrolled in or the professor that is teaching you. Okay, so that is when the questions are more tricky, and you have to base on the experience that you have, or the learning and the understanding that you have gotten so far to answer those questions. Right now, see what has happened over here. If you see the results, right. The guessing woman over here, she got 47%, right, which reflects what she's been doing so far, right? And then if you see Mr. Know It All, right, now he's getting 69%, right? Because during the class, Mr. Know It All memorized everything that the professor was teaching. But this is national exam, right? This is national semester exams. Okay, in the class test and stuff like that, your professor is the one going to set. But at the end of the semester, it's going to come from the national board. Okay, national examination board. In that case, it's not going to be your professor's method. Okay. And in that case, since he already has some prior knowledge and stuff like that, he will be able to score some good marks over there. But since they are not going to be exactly what the professor has taught him, right, his performance is not going to be as great as he used to have it when the professor is the one setting the questions. Okay, but this person who is more pragmatic and more problem solving, uses more problem solving approach, right, is having 89% over here, right, as against what she was having earlier on. Now, since she knows, since her approach is problem solving, right, even if she has not seen the question before, she can still reason through it, and then the process that she's supposed to take and then come up with the solution, right, she can still follow the process and then come up with a good score. Okay, because her approach is more general. Okay, her approach of solving questions is more general, unlike this one, which is more custom to the professor that is teaching him. Okay, this one's approach is more custom to the professor. He knows the professor's techniques and stuff like that, so he can score more, right, when the professor is the one teaching, right? But this one's approach is more general, so irrespective of the one who is setting the question, she can still score more. Okay, she can still score more irrespective of the person who is conducting the test, or wherever the test is coming from. Okay, now you can see these three people and how they are performing if they have not seen the questions before. Okay, now let's put all of them together over here, and then you're going to see how things are unfolding over here, right? So now this is their entire results. Okay, so during the class test, right, this person, that is student A, who is not really interested in the learning, right, in the class test, she managed to got 50%. Okay, because they are all aware of the professor, they all know the professor, and even with guesswork and her little attention that she paid in class, she was still able to get 50%. But during the national test, right, things became way worse for her, right, because that is a completely strange field. Okay, and then Mr. Know It All memorizing person, right, during the class, since he has mastered the techniques of the class, the professor, he was able to get 98%. But when it came to the test, right, or the one that came from outside that he has not seen before, the performance reduced drastically to 69%, right? And then this lady here, who is more into conceptual learning or using more pragmatic approach of approaching situations or problem statement, her performance reduced, but not much. You can see that she's still doing well, okay, because she learned it in a more generalized way. And even though the professor is not the one setting the questions and things became more difficult or tough in the neutral field, she was still able to pull through and came up with 89%, which is good. Okay, now if we relate this one to machine learning, right? If we relate this one to machine learning, we say that the one who is not doing well in both of the exams, right, underfit, or we call that situation underfit. Okay, and then the one who memorized too much during the learning stage, okay, he memorized way too much during the learning stage, but when it came to the data that or the test that he has not seen before, right, he started performing way worse. And in that case, we call it overfit, right? He overlearned the professor's techniques. Okay, he overlearned the professor's technique, and instead of him trying to learn some generalizations over there, so that, or the pragmatic way of learning, so that he can be able to do well, even if he has not seen the questions before, he didn't do that. He was just focusing on memorizing and impressing the professor. But when the data came in that he has never seen it before, or the style of setting the questions he has never seen before, the performance dropped drastically, right? And in that case, in machine learning, we call it overfitting. Okay, that is doing well on the training but doing poorly on the testing. Okay, and in this person, if you consider this person, right, during the training she did well. During the testing too, she's doing well. Okay, and that is the best fit. That's what we want. Okay, in machine learning, we call it the best fit, where you do well both in training and in testing. Okay, but if you do well in training and you do bad in testing, that is overfitting. And if you are not doing well in any of them, that is underfitting. Okay, if you are not doing well in any of them, that is underfitting. So I hope this one give you a clarity of what underfitting, overfitting is, and what the best fit is. Okay, you can just rewatch this video one more time up to this stage. Okay, I'm just going to do one more thing over here for you to have a summary of it. Okay, so in machine learning, it looks something like this. Okay, it looks something like this. So you have your data, right? In regression, I've given here regression, then I'm giving here classification. That is in two scenarios, okay, where we do regression and then where we do classification. Okay, remember this overfitting and then underfitting is going to happen when you're doing supervised machine learning problems. Okay, where you have a target where you want to predict. Okay, supervised ML. Okay, supervised ML problems. Okay, now in regression, all we try to do is to make sure that we fit a good we have a best fit line where we're going to base on that and then make feature predictions. Okay, so if you see this way, if you see this one, right, it's not this line is not fitting anything here, right? If you see how your data is and how you're fitting the line, right, it's not able to capture many of the data points here. The error is going to be very high. Remember that all we try to do here is to minimize the error. Now if I measure the errors over here, if I measure all the errors over here and try to find the summation of these errors, right, it's going to be very big, right? It's going to be very big because you can see the data points lie very high. Unlike the one which is the optimal fitting, that is the one that we want. You can see that it's capturing majority of the data points. Okay, it's capturing majority of the data points, right? So here if you measure the errors, it's going to be a bit lesser. Okay, the errors are going to be lesser. Okay, now if you see the overfitting one, you can see that it's trying so hard to impress us, right? It's trying to so hard to capture each bit of data point that it can capture. Okay, it's trying so hard to capture each bit of the data points over here, meaning that during this training season, it's trying so much hard to memorize everything that it can. Okay, according to the data points. But if we take this one and you feed it with a new data point, right, which is going to be like the test data or the real world data that it has not seen before, if you feed that one, it's going to do very bad. Okay, here it's going to perform very, very well, like maybe 90% or something like that. But if you feed it on the test data, it's going to go down to something like 60%. Okay, it's not going to do well, and that is when we refer to as overfit. Okay, it's overlearned during the training time, but during the test time it's going to perform badly. But here it's not going to do well either on the training or the testing. Okay, but here it's going to do as much well as it can during the training and also during the testing. Okay, now if you consider classification, what we do is to try to separate points. Okay, so either the customer will pay back the loan or not, so it's going to be yes or no. So if let's say the blue point represent yes and the red point represent no, okay, what we try is to separate the yeses from the no as much as possible. Okay, and in this case, if you see over here, right, although it's trying to fit this line, but you can see that majority of the blue points are not being classified very well. Okay, and these ones are having some red points right over here. If there were no blue points over here, we will consider this error as okay, because we've been able to separate much of the red points. But you can see most of the blue points are also here. Okay, so this one is not able to do it well. And if you see the optimal one, all right, if you see the optimal one, you can see how it is able to separate as much red from the blue as possible. Okay, and if you see the one that is overfitting, it's trying as much as possible right during the training to capture each single thing over there. Okay, each single thing over there. In this case, it's just memorizing these things, and it's not going to do well if we take this one to production. Okay, so we want the model that is going to generalize. Okay, that is going to generalize for us in production, but not either this or that. We don't want any of these ones. Okay, we don't want any of these ones. Okay, now let's summarize everything that we've done so far up to this point. Okay, let's have a summary of everything that we have done so far. All right, now let's say that we have built our model. Okay, so let's say we have built our machine learning model. Now we're going to determine whether this model that we have built is going to be overfitting or underfitting. Okay, now let's say I'm just gonna put this thing over here. Let's say I have just gonna do this thing, right? I just want to summarize everything for you, right? I know now, by now you should be able to understand whatever that we have done, but I'm just going to summarize it over here for you. Okay, so let me I'm going to change this color over here, right? Then I'm going to use something like this. Let's say when we created the model, right, on the training data. Okay, so I'm going to put training over here. When we tested the model on the training data, after creating the model, right, when we tested it on the training data, we're having an accuracy something like 80%. Okay, something like 80%. Now let's say that we test this, right? We test instead of the training data, now we use the test data to test the model to see how well it's doing. Now let's say on the testing data we are getting something like, say, 85%, right, or maybe 75, right, 75, right, or maybe something like 90, right, something like that. Okay, let's say we are getting something like that. Now you can see that the values are just around 80%. Okay, they are just around 80%. Okay, the values are very, very close to 80%. In that case, we say that we have the best fit. Okay, we have the best fit. Okay, we have the best fit. Now let's consider another scenario. Okay, let's consider another scenario. So I'm going to use this color over here. Okay, let's consider another scenario. Let's say that on the training data, right, when we test our model on the training data, okay, we got an accuracy somewhere like 60%. Okay, something like 60%. And then on the testing data, right, on the tested data, we got something like let's say 55%, right, or maybe 62% or something like that. All right, something like that. Now in this case, right, if you see the accuracy that we have here, even on the training data that it has already learned from or it has already memorized, it's not doing well. Okay, 60% is just not a good accuracy. Okay, and if you test it, and the testing data, you can see that it's also not performing well either. Okay, it's not performing well either. In that case, we say that it couldn't learn. Okay, it couldn't learn well, so we call it under. Okay, we call it under fit. Okay, it has, fit means learn. Okay, so it has under learn, right? It didn't learn very well. Okay, now let's consider another scenario. Okay, let's consider the last scenario over here. Okay, let's consider the last scenario. So let's say that on the training data, right, I don't want the color to be like this. Let me just change it a bit. Okay, let's say on the training data we are getting something like this. On the training data we got something like, say, 92%. Okay, and then when we test it on the test data, let me close this. On the test data, right, when we test it on the test data, now we are getting something like say 70%, right, 70%, or maybe we are getting even something like, say, maybe 68% or something like that. Okay, now in this case we will say that it is over fit. Okay, meaning that during the learn stage, fit means learn. Okay, so it has overlearned. Okay, during the learning stage it learned too much, right? It learned too much, it memorized things, and when we try to bring in a data that it has not seen before, it's doing poor. Okay, it's doing poorly. So in that case we call it what? Overfit. Okay, so you can just see this one and then make sure that this one stick into your head, right? Anytime that you hear overfit, underfit, you should be able to see this one. Okay, in this scenario, I'm just going to use this over here. In this scenario, right, it's doing well on the training data, okay, but it's doing very bad on the testing data. Okay, and in the second scenario, in the ideal scenario, it's doing well on the training data and also on the testing data. Okay, and in the underfitting scenario, it's not doing well on the training data and it's not also doing well on the testing data. Okay, now you can just keep only this part as well. Okay, only this part, and this is going to stick with you forever in your career. Okay, this should stick with you forever in your career. Okay, as soon as you see this image, you always get to understand or remember what overfitting and underfitting means. Okay, as soon as you see this one, you should be able to understand what overfitting and the underfitting means. Okay, in the next tutorial, I'm going to show you what is meant by bias variance trade-off. Okay, which is one of the also another hot topic over there, another crucial topic over there. Okay, it's quite complicated according to those who are trying to enter into the field, but I'm going to break that one down for you to really get to understand it, what bias variance trade-off is all about. Okay, you're going to understand, you're going to enjoy that one as well. All right, so see you in the next tutorial.